but you have to know how to sum things. And most of the series you cannot sum, but at least when it comes to geometric series, telescoping series, you better know how to sum, right? Okay, so you have to review partial fractions and things to deal with telescoping. Okay. And number 13, this one is 1 minus 2 factorial over 1 times 3 plus 3 factorial over 135 minus 4 factorial over 1357 plus blah 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 alternating. So the nth term takes the form of -1 to the n minus 1 power n factorial 135 up to 2n minus 1. What is the next term? Well, next term, several things happen. Of course, you'll flip the sign again. Is that right? Okay? But if I only care about the absolute values, then that doesn't matter. M factorial becomes what? M plus 1 factorial, so extra factor of m, m plus 1. Downstairs, 1, 3, 5, all the odd numbers up to 2m minus 1. For example, up to, say, 7. Then the next term is 1, 3, 5 up to what? 9. 1 extra factor, not 2, right? 1 extra factor, right? Okay, so put together, I concluded that the next term, absolute value divided by this term, absolute value, taking the limit, this is taking the limit, well, what is that ratio? I have extra m plus 1 in the numerator, is that right? Denominator, I have extra what? Here is 2m minus 1. The next term, you have all these along with 1 extra, just like 1, 3, 5, 7, next one, 1, 3, 5, 7, 9. Just 1 extra factor. That is the last one, which is 2m plus 1. Is that right? So what is this limit? 1/2. Less than 1. And therefore, what's the conclusion?
Absolutely.
Converges absolutely. By what? The ratio test. Number 14. Number 14. Summation n goes from 1 to infinity. N to the 4th power, 4 to the nth power. What's the difference? N to the 4th power, 4 to the nth power. Which one is more scary?
The bottom.
The bottom. Right, sort of exponential growth, right? Right. This one is power growth. It's nothing. I mean, nothing in comparison with exponential growth. That's what I'm saying. And so, n, a n plus 1 absolute value over a n absolute value. Actually, everything is positive, right? Okay. Limit n goes to infinity is equal to limit n goes to infinity. Hold on. This is what? 14? Okay. Right. Okay. So in going from one term to the next, in the next term, n to the 4th power is replaced by what? N plus 1 to the 4th power. So you have to get rid of n to the 4th. So divide by n to the 4th and replace it by n plus 1 to the 4th. That's one thing. Second thing is the denominator goes from 4 to the nth power. Now it becomes 4 to the n plus 1 power. 1 extra factor of 4. So like this. So what is this limit?
1/4.
1/4, which is less than 1. And therefore what?
Converges
absolutely. Converges absolutely by the ratio test. All right, number 15. Number 15. Summation n goes from 1 to infinity, -1 to the n minus 1 power, square root n plus 1. What happened? Do you think it's absolutely convergent?
No,
No, why not?
because the P series less than 1.
Yeah, because if you see that, forget about a sign. If you take the absolute value, the top is square root n, right? Denominator is n plus 1, right? So top is degree 1/2, bottom is degree 1. So 1/2, 1, so cancel out, I mean approximately. And so you get 1 over something, which is
End of that.
power 1/2.
Yeah.
Yep.
Right, so it's P, it compare with P series, what P? 1/2, which diverges. And therefore, this absolute value series diverges. So we have no hope of arguing that it absolutely converges. It's definitely not absolutely convergent. At most, we hope that it's conditionally convergent. Is it? I think so. All right, so how do you prove that? Well, so you see that an absolute value, let me clean up the absolute value part first. The absolute value is square root n over n plus 1, all right? And then compare with summation n goes from 1 to infinity, 1 over square root n, right? Okay? Then square root n over n plus 1 over 1 over square root n. The limits n goes to infinity is equal to limits n goes to infinity n over n plus 1 as it turns out, which is 1. And therefore, but this positive series n goes from 1 to infinity, 1 over root n is a P series with what? P equal to 1/2. So it diverges, and therefore, summation n goes from 1 to infinity, absolute value of an also diverges because by what? Limiting comparison test. So this shows that absolute value series diverges. So the original series definitely is not absolutely convergent. But how about, is it conditionally convergent? Well, I think it's yes. And how do you show that? Well, okay, now the series itself is alternating, right? Now look at square root n, an. So an is equal to -1 to the nth power bn, is that right? And so this bn is the absolute value part. Bn is what? Square root n. By bn I mean square root n plus 1. Would you agree that this guy is how do you show that it drops? How do you show that it drops?
Derivative.
Now you take derivative, okay? So, do you still remember logarithmic derivative? Anyway, maybe just those in my class, you have last semester you remember how I deal with this. It's not the only way to deal with it, but just take this opportunity, right? And you do not have to do a formal, logarithmic differentiation. Instead, you can argue this way. You say that I'm going to take the derivative, all right? Okay, and you think of this as the product, right? Okay, and then I'm going to use product rule. Therefore, I'm going to differentiate this one, and then I'm going to differentiate that one. When I differentiate this one, it's a power function, so two things happen. What power of this is 1/2, and therefore you multiply by 1/2. Is that right? Power drop by 1. What do you mean power drop by 1? Divided by 1x, 1 over x. All right? Plus, how about second factor if I differentiate? Second factor is x plus 1 to the what power? -1 power. So when I take the derivative, two things happen. The first thing is that -1 power get pulled to the front. And secondly, a power drop by what? Power of what drop by 1? Power of x plus 1 drop by 1. So it's 1 over x plus 1. Right? But of course, you have to use chain rule. That means that you have to multiply by x, derivative x plus 1 with respect to x, but that's just 1. All right? So that doesn't introduce anything. And therefore, you get this. And then, so this factor apart, you have what? You have 2x times x plus 1. Is that right? Okay? And then, if you make out a common denominator, and 2x, x plus 1, this one becomes x plus 1, and this one is minus what? 2x. Right? And therefore, this becomes square root x, x plus 1. And this one is 1 minus x, isn't it? And this is 2x, x plus 1. Right? So isn't this negative? Is that right?
Yeah.
If x is greater than 1. Is that right? So that's good enough. So at least I know that this bn thing, at least I'm erasing this announcement of midterm. I hope everybody knows, right? Okay. So this bn, I know that it is, first of all, positive, right? And secondly is eventually, actually very quickly, as it turns out, right? Eventually what? Going down. And then limits of bn is obviously what? Is limit n goes to infinity, square root n of n plus 1 is what? 0. So, summation n from 1 to infinity, an is equal to summation n minus 1 equal to n goes to 1 to infinity, -1 n bn converges what? By what test? Alternating series test. Right? So, what's the conclusion now? It doesn't converge absolutely, that I know, but then I managed to prove that it converges. So what is the conclusion? So answer is
Converges.
Converges, but converges conditionally. So this is a case of conditional convergence. So this is number, what time is it? Oops, past time.
You said
This is 15,
Yeah,
and there are 10 more.
because he called it x plus 1, and then you drop that by, you
I'm
bring
going to
out
post
the
the
negative 1,
solution online.
and then you,
Yeah, I was trying to follow what he did, but I
but
don't know.
I think it's x plus 1 squared, like 1 over x plus 1 squared, I don't know, I
I was trying to do
almost
it.
can't remember how to do it.
Is it, isn't it when you do the differentiation of the x plus 1 at the bottom, does that not become x plus 1 squared?
Yeah.